Thank you for joining this lesson. We're going to continue with the Kapsabet High School Mock Paper 2 Mathematics. Remember to subscribe to this channel and to also share the link with friends. We are already in number 3 and I'm going to solve it in this lesson together with number 4. Make x the subject of the formula. So we have a formula given here and we're going to change the subject of the formula from b to x. So allow me start by multiplying by x all through to have bx being equal to c, the root of x squared minus 1. Then at this point now, I can talk of dividing by c, which means b x out of c equal to square root of x squared minus 1. Then at this point now, to do away with the square root sign, I can square both sides such that I'm going to have b x out of c squared equals to x squared minus 1. And at this point, we can now have b being squared, x being squared out of c also squared. This is equivalent to x squared minus 1. So at this point, allow me group the terms with x together such that when I bring 1 to this side, it will become positive. Then at this side, I will have x squared minus b squared x squared out of c also squared. And at that point, I can talk of 1 being equal to x squared. Now we remain with 1 minus b squared out of c squared. Remember now, x squared, which is appearing twice, could be factored out. That is why we've done so. Then at this point now, you can allow me remain with x alone by dividing through by its coefficient. So to remain with x squared, then we have to divide 1 here by 1 minus b squared out of x c squared, that is. Then now with this, we can remain with x by taking square root both sides. Square root of x squared is x, and the square root of the other side now will be plus or minus the square root of 1 out of 1 minus b squared out of c squared. This can further be simplified anyway into x being equal to plus or minus the square root of 1 divided by, when you check 1 and this is a minus, then we have b squared out of c squared. That's a difference of 2 squares, and we can further simplify it to 1 minus b out of c into 1 plus b out of c. So that can be a further simplification of the same problem. In number 4, we are told that in the figure below, O is the center of the circle, line AB is parallel to DC, and angle DC, that should be ADC, equals to 55, just as indicated in the diagram. Determine the size of angle ACB. The angle here is the one in question. All right, we can start applying a few properties of angles in a circle. And here we can start by saying, because O is the center and line DC is passing through the center, then we can conclude that DC is a diameter. Now that DC is producing an angle or subtending an angle at this point, then that angle is 90 degrees. Angles subtended at the circumference by diameter are always equal to 90. So with 90 and 55, then we can talk of the value of this angle being 35. Yeah, because inside the triangle ACD, there should be 180. So with 90 and 55, the other angle becomes 35. Now that AB and DC are parallel, then it means AC is acting as a transversal. This one is a transversal line, and therefore the angle here and the 35 we've gotten become what we call alternate angles. And the angle at A becomes nothing but a 35 also. Alternate angles are equal. So that is also a 35. Again, because A, B, C, D are vertices which are touching the circumference of the circle, then we can say that ABCD is a cyclic quadrilateral. And so the opposite angles in a cyclic quadrilateral being supplementary, and this is already 50, that's already 55. Then we can talk about 180 minus 55, so that we may say that the angle at B is 125. So the angle here is 125 degrees. Now with 125 and 35, the angle at C can be obtained very quickly, because we will talk about the angle ACB. That will be 180. Then we subtract 125 and 35. 125 and 35, they are giving us 160. So when we take 180 minus 160, we get exactly 20 degrees. So the angle at this point is only 20 degrees. That is the value.